Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 35, which is based on speed control of hydraulic cylinder or motor. The orientation speed of a motor is determined by the displacement of the motor. The relation between the flow rate Q and the displacement of the motor Vd and the speed N is given by the equation which you can see on the screen, which is nothing but Q is equal to Vd into N, or it can also be simplified as N is equal to Q by Vd. Therefore, from this equation it can be observed that the speed of the motor is a function of the discharge and the displacement of the motor, that is Vd, and the larger the flow rate Q, larger will be the speed and vice versa. In case of gear motor, the physical dimensions are fixed and hence the Vd cannot be varied. That is why it is called fixed displacement motor. Hence, the speed of a gear motor is completely dependent on the flow rate of the fluid into the pump. By varying the flow rate, the speed of the motor can be controlled. In the case of vane motors and axial piston motors, the pump displacement can be varied by varying the eccentricity E and the swash plate angle respectively, which were discussed in previous sessions. Hence, speed of the vane motors and axial piston motors can be controlled by the flow rate Q and the displacement Vd of the motor. In addition to this, the direction control of motor can be reversed by changing the direction of flow of the fluid using a direction control valve. Then we'll understand one more concept that is called as speed control and reversing of direction using a pressure compensated flow control valve and a direction control valve. It consists of a pump P driven by a prime mover M. The output or discharge from the pump is connected to the pressure compensated flow control valve, which shows in the hydraulic circuit of the same in the slide right now. Then let us understand how it works. In the center of position of the direction control valve, no flow takes place into the motor and the motor is hydraulically locked. When a direction control valve is actuated to the left, manually using the lever, flow takes place into the motor HM through the ports P to A and the motor rotates in one direction. When the lever is released, due to the spring action, the direction control valve spool is brought to the center of position and cut off the supply to the motor and the motor stops. When the direction control valve is actuated to the right by the operating lever, flow is diverted to the motor in the other direction through ports P to B and the motor rotates in the other direction. Based on the external load on the pressure, compensating flow control valve maintains constant pressure drop across the throttle, thus maintaining a constant flow into the motor and hence the speed. This is how it is going to control it. And also we will understand one more concept that is called as braking system for hydraulic motor. Due to consideration should be exercised on the type of loading a hydraulic motor would experience in hydraulic system. When a hydraulic motor is driving a load of large inertia would create a flywheel effect and stopping the motor would cause it to the act as a pump and draw air to it. This effect of drawing air can be prevented by designing a circuit which you can see in the slide. This also serves to discharge the fluid from motor to be returned to the tank either unrestricted or through relief valve. This would stop motor rapidly without damaging the hydraulic system. Then we'll discuss a concept called as accumulator applications with circuits. Different types of accumulators have been discussed in previous uh, sessions, and each having its own advantages, disadvantages, and upon the applications of this, from the application point of view of accumulators can be used as an auxiliary power source, a leakage compensator, and an emergency power source, and a hydraulic shock absorber. We'll discuss each and every one by one. Now let us discuss an auxiliary power source. One of the most common application of accumulator is to use it as an auxiliary power source. In this application, the accumulator will store oil delivered during a portion of work cycle. The oil so stored is released by the accumulator on demand to complete the cycle, thus serving as an auxiliary or a secondary power source. This will help in using a smaller size pump in system where intermittent operations are performed. The figure shows the circuit diagram of such an application. The accumulator is used in conjunction with 4 by 2 manually actuated spring return direction control valve. When the valve is actuated, oil flows from the accumulator to the head end of the cylinder and extends the cylinder. When this operation is being performed, the accumulator gets charged. When a direction control valve is deactivated, the cylinder retracts rapidly because the oil from both pump and the accumulator is directed to the rod end of the cylinder. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan.